Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Crash Course in Open Source Cloud Computing. Our guest speaker today is Mr. Ravi Gururaj, VP Products Cloud Platforms Group at Citrix System Inc. Mr. Ravi Gururaj has 20 plus years of technology development, management and marketing experience. As VP Products, he manages the Cloud Portal Business Manager Product Group, is a member of the Citrix CTO Office, is responsible for regional coordination of the Citrix Startup Accelerator Program in India, and serves on the Citrix India R&D Engineering Leadership Team. Mr. Ravi is the charter member of TIE, a founding member of the Harvard Angels of India, and is a frequent speaker on the topics of enterprise-grade virtualization, cloud computing, and entrepreneurship. Mr. Gururaj received an MBA with high distinction from Harvard Business School, where he was elected a Baker Scholar, and graduated with honors from the University of Pennsylvania as a Benjamin Franklin Scholar in the Management and Ecology program, receiving a BSc in Computer Science and Engineering from the Murray School and a BSc in Finance from the Wharton School. Mr. Ravi spent time as a research scholar at the University of Edinburgh and was schooled at the La Martiniere School in Kolkata. So without further delay, I introduce you all to our guest speaker, Mr. Ravi Gururaj. Over to you, Mr. Gururaj.
Thank you, Moni, and welcome to everybody to this webinar. Thank you very much for attending. I will now display my screen, and hopefully everybody is connected and is seeing a slide that says delivering infrastructure as a service with open source software. Moni, can you confirm?
Yeah, we can see your slide.
Very good. Thanks very much to everybody for joining. In today's agenda, essentially, I think Mohani's already covered the first item, the personal introduction. Thank you for that. We will also cover a quick overview of cloud computing, and then talk about the building blocks of open source itself, how you use open source to build a cloud platform, and then talk about tools that are used in cloud management that are widespread and popular. And then specifically, we will, in our last segment, talk about CloudStack and how you could build an open source-based cloud platform and a cloud offering within your organization, or if you're a service provider for your customers, using CloudStack as the fundamental building block. And we will take questions. Please jot down your questions and type them into the chat window as you go along. We'd be glad to address them at the end. So this is a relatively long presentation. In some instances, I will skip over slides in the interest of time, but feel free to raise any questions that you have in the chat window. So, cloud is a much hyped term nowadays, and lots of things are being called cloud. But I just wanted to level set on basic fundamentals of what is cloud in this presentation before we move forward into much greater depth. So essentially, there are 5 characteristics that we see in clouds. One is it's on-demand and self-service. That is, users can come to either a console or through an API or through command lines and instantiate for themselves resources on demand in whatever level of or to whatever extent they need, right? The second is it has broad network access, i.e. you have lots of different ways in which you can set up networking, and you have resource pooling. That is, you have aggregation of resources across users, and you have extreme elasticity, so you can scale up and scale down as you wish, and all attributes on all different vectors are measured, and you get essentially levels of service that are guaranteed in both performance and in quality across the board and across the platform. So those are 5 big characteristics that we see across the board, and what kind of define cloud. So I think one area that you all are probably all familiar with and is probably well understood is kind of the layering of cloud. Right on the bottom of the stack, you have the IaaS layer. Above that, you start to see very rich platforms that allow you to build essentially applications. Those are the PaaS layers. And then above that, you actually have applications themselves that are running in the cloud that are multi-tenanted and are available from any device in any location, and essentially deliver applications to end users. And even in federation with other applications similarly in kind of a multi-portal view. So, the deployment models that we see, and again, these are the basic kind of overview of cloud itself that I'm running through now before we dive into depth here. The deployment models we see are three. Essentially, you have the public clouds that are well known and popularized by Amazon, Azure, and a whole bunch of others that are in that space, including SoftLayer and Rackspace and all of those. And then you have private clouds that are built using either virtualization or cloud-like technologies like CloudStack and others in the private data center. And then you're starting to see increasingly the hybrid cloud that essentially amalgamates both of these types of clouds into a single both infrastructure layer and a single management pane of clouds, right, across the board. And within a private cloud, and just kind of diving into a greater level of depth here, what you see is essentially the layering that shows essentially the physical layer at the bottom. You see essentially a virtualization layer that's provided through a hypervisor, or basically it could be either be a Xen-based hypervisor, VMware, or Xen Server, or KVM. There's a whole bunch of options there. And then you have virtualized resources that are presented to the layers above, right? The PaaS, the IaaS, the SaaS layers. So, and then you basically have the endpoints that are at the highest layer above. And on the right, we show you kind of all the different layers of management that are typical for private cloud management. And this would look very similar to what you would see in a private data center scenario as well, in terms of all the different dimensions on which you need to manage your resources and your infrastructure and monitor them. So not dissimilar in terms of the management stack, except the architectures and the approaches are slightly different, obviously. So, when you talk about scaling out in the cloud, again, you hear two very common terms, scale up and scale down. And what do they mean, really? Vertical scaling is scale up, which is you basically take your individual workload and you just grow it. So, the fact that you have a virtualized workload allows you some flexibility in being able to take that workload and add to it either CPU resources, memory resources, disk resources, sometimes even on the fly, and be able to essentially scale up. But there's a limit to that. But one of the advantages of that is you don't have to you don't have to re-architect your application. It's legacy compatible. You may need to, when you reconfigure, reboot the configurations. But then, there's some limits to this, right? Which is essentially a single instance can only grow to a certain amount that your physical resources may be able to accommodate. And it also, once that single instance is very large, it becomes potentially a point of failure, right? A single point of failure. Now, you could find ways to make it highly available, but they're generally suboptimal relative to other architectures that are available. So then you've seen the need for scale out that's come. When people said, okay, scale up, or we've reached the limit of scaling up, let's start to scale out, and you started to see a lot of that happen in the architectures that we see on the web, especially, where you see, for instance, large web farms that are basically horizontally scaled out using a combination of things like HA proxy, Apache, Hadoop, whatever. And, cloud infrastructure stacks need to support that as well. So essentially, any stack that you select needs to be able to support these two models of scaling, right, which is basically being able to scale up and scale out. Both of those are very important. So, one of the things about cloud is that you still need to, just because you've gone to cloud doesn't mean you can ignore design and you can ignore your architectural issues, right? Cloud doesn't magically solve some problems. It's not some silver bullet, right? You need to ensure you've taken architecture into mind, that you've made sure your infrastructure is easily replicable, that you've thought through the scale out, both scale up and scale out attributes that you need to imbue into your cloud, and that you've taken all of these constraints and all of these dimensions into mind while building out your infrastructure. So, essentially there's no magic bullet in cloud, right? So how do you build, a cloud using kind of open source software, right? And we'll go over that a bit here. So, what is the fundamental underpinnings of open source in the first instance, right? So why would users flock to open source based cloud building blocks? And essentially, one of the big reasons is user driven, and the community drives this. Community built solutions are often much better at addressing the real problems of users than something that is much more prescriptive. You tend to have much larger user base because of the widespread adoption of some of these technologies and the large community, and it's the support systems are within the community where users end up helping each other. Also, because the price point, at least the initial price point, is almost zero, and because it's open source, there's very low barriers to entry and participation in the community. In fact, even individuals can participate, and all the way up to very large corporations can all participate on an equal footing in the community, and that gives a sense of a democratization, right, of the process, and brings in a larger set of folks to the table. And also, generally open source projects tend to have pretty aggressive release cycles to stay kind of at the bleeding edge, and you get to try the software before you buy it. In the classical sense, you don't need to make a large commitment up front. You can go today, for instance, and download CloudStack and give it a shot, and only then come back if you wanted to buy a supported version of it. Come back and buy support, right? And finally, all of these stacks are built on a very open, flexible, malleable standard, right? That is open both in the standard itself and open in the community and the philosophy of kind of how it's maintained. And that's a very important selling point for the people who adopt open source, right? Because essentially they're making an investment and they don't want to see a lock-in in terms of the technologies that they're implementing. So one of the open source standards that has made a reasonable amount of progress in recent times is the OVF format, right? And really, it's the open virtualization format that is essentially a standard for how you package up and distribute a virtual appliance. And it could be an appliance that is a single instance of a single virtual machine or even multiple virtual machines in combination. And the standardization process is still kind of a work in progress, but it's essentially a way of bringing together all the disparate types of formats we've seen out there that support a virtual machine, right? And I've got a few instances of those below in terms of the different formats out there. So this is a good standard for you all to understand in terms of what you look at in the actual the packaging of the virtual machine itself, or even groups of virtual machines as an appliance. The other areas where we're starting to see some good tools being developed is how do you actually build out your appliances? How do you actually put your virtual machine together? And Bitnami, Box Grinder, even the SUSE Studio and UShareSoft, are great examples that you might want to review of how you'd create a server template from essentially build out a bare metal VM for yourself. How would you do that programmatically? How would you set up templates that would kind of allow you to manage those base installation of the bare metal software stack on top of essentially what is a software virtual machine, right? The open source hypervisor choices that you have, again, you've got both open source and proprietary choices, and on the open source side, the Zen is probably the most widely used hypervisor. In fact, it is the most widely used hypervisor in the cloud. KVM, VirtualBox, and a whole bunch of others are good choices as well, but clearly Zen dominates there. On the proprietary side, you have essentially all the big vendors that have choices as well, from VMware to Citrix and Server, Microsoft Hyper-V, and Oracle, and they have a hypervisor as well that's available. So these are all the choices that you need to keep in mind. Each has its pluses and minuses. In terms of the stacks themselves, and that you can go out today and get yourself in terms of building out an open source cloud. Here are the four big choices that we see. And CloudStack, and this is obviously something that Citrix is very deeply involved with, but there are others as well that you could consider: Eucalyptus, OpenStack, and OpenNebula, right? Numerous other companies are working to build out stacks based on variants of these in the market. Storage is another area that you'd have to consider as you build out your cloud, and here are some of the choices that we've seen out there. Gluster, you've got OpenStack, Swift itself, Sheepdog, and you can just use NFS itself to build out your stack. So, you'd want to consider all of these choices as you move forward, in terms of how you would build out your storage. And then, if you're going to actually programmatically build out your cloud and build tools that essentially interface with the cloud, there are some tools out there that we've seen that allow you to abstract away multiple different types of infrastructure layers using a common API layer. And these are suggestions that we've seen out there in terms of JCloud, libcloud, Delta Cloud, Fog. These are all different API libraries that allow you to access a set of cloud resources in a uniform manner, even though you may have heterogeneous clouds under the hood. So, OpenStack and basically the platform as a service area for open source. These are some of the choices that we've seen out there. You've seen OpenShift from Red Hat. You've seen the Cloud Foundry, which is a VMware sponsored project. And you have others as well that are in the market that allow you to kind of build out an open source PaaS layer if you're interested in that. And so, one of the things about cloud that we often hear is, this whole thing about, cloud's extremely reliable, and, and you often see vendors and service providers quoting a certain reliability number, if it's 6, 5 nines, or, and, you've got to understand what that means and what underlies that, right? And so, one of the learnings we have is, the reliability or unreliability, as we like to call it, is really something you need to deal with. So what is unreliable? Pretty much everything is unreliable. You have to assume that when you're architecting your cloud. Who is unreliable? It's oftentimes the people who are managing the cloud are the ones that are unreliable, because you have human error that happens, right? Oftentimes, and it's the people who are touching the cloud who are sometimes unpredictable and do things that are unexpected, right? One funny thing we've often come across is when does unreliability happen? It almost always happens at the most unexpected of times, in the middle of the night. And I've heard sysadmins say it always happens at 3 o'clock in the morning, regardless of the time zone. And when does it happen? When does unreliability happen? The paradox of things is, it often happens in the most well-planned data centers, right? And where everything has been taken into consideration, and that almost defines unreliability, right? When you thought everything was reliable, you had something that happened that was unexpected, and that's the area where you need to plan the most. And unreliability, how does it happen? It happens rather nonchalantly. What do I mean by that? It'll often happen as something that's a very small, innocuous little thing will start to happen in your data center, and then it'll start to grow, and you'll first be able to ignore it a little bit, and then suddenly it will overwhelm you, right? And you need to kind of keep guard against that happening. Very important. So what do you deal? How do you deal with this unreliability issue and manage for it? So don't assume anything, and I think you've got to be prepared for it and be able to deal with it, and don't bang your head against the wall, and you should be able to kind of figure out how to ask for help when you need it, because there are others that will be able to help and may be able to, and especially if you have communities that are helping you, be able to put solutions together for various reliability factors, right, that you want to achieve. So the next segment of this presentation is talking about kind of the tools we're seeing that allow you to manage an open source cloud. And so let's walk through a bunch of those that we are seeing very popularly used, right? But before I do, one of the things that is talked about in terms of cloud is, this is Jevon's paradox, right? And that says basically, as this is this paradox, which is as you increase the efficiency with which a resource is used, this tends to increase, rather than decrease the rate of consumption of that resource. So, in the cloud computing kind of parlance, as you increase the consumption, it can actually increase, significantly the management overhead, despite higher benefits, right, of hardware utilization or other things. So it's a paradox that you see that was actually first thought through by this English economist, right, Jevon, in the last century, and it's so true in cloud as well, which is, the more efficient it becomes, the more you use it, and the greater your dependence on it, right? And so there's two ways people have kind of tried to address the reliability methods, right? In the old data center, you used to use kind of the brute force approach, which is throw people at it. In fact, you'd have a cloud of people, often referred to as the meat cloud, right? That is, you have a cloud of people, each with different domain expertise, each an individual person who can solve individual sets of problems in specific areas. And that's great for a small data center. You're always kind of fighting fires, but that's not the way you can run a cloud, a true large-scale cloud. It just doesn't work. In the cloud, what we're seeing is really high degree of automation. We're seeing essentially autonomic kinds of processes, extreme levels of management and monitoring using tools, and remediation that is almost automatic, right? So cloud ops are really kind of almost self-healing in some sense, ideally, and certainly self-discovering and alerting in terms of faults for sure, right? So going back to the reliability, when you start to see kind of 6 nines and 5 nines bandied about, what does that really mean? When you kind of look at it, you start to see, okay, if you had somebody say, my X is 5 nines reliable, that means, you can have at most downtime of 5 minutes in the year. Now, in the context of cloud, what does that mean? If you have, hundreds of thousands of objects out there, or even millions and hundreds of millions of objects out there, which are very large clouds do, it means, the polling frequency has to be extremely well managed so that you don't overwhelm the infrastructure layer with polls. So if, let's say, you set your polling frequency of 5 minutes or something, essentially, even to achieve 5 nines, you would not be able to achieve that literally with just the poll, right? And practically, it would take almost superhuman operations, right, for people to be able to react within that time frame. So, take a little bit of these reliability numbers that are bandied about with a grain of salt, right, in terms of, what is 4 nines and what is 3 nines, are those really achievable? And be aware of what you're trying to architect for, right, and what guarantees you're banding about. Very important to kind of consider this in the context of cloud, in the context of the overhead of polling that when you have hundreds of millions of objects potentially in your cloud, right, that need to be monitored. Again, I just throw this out there for food for thought, right, in terms of what kinds of reliability are you trying to establish. So how do you actually manage a cloud? One of the big things is, we've gone to a philosophy that says, we need to find tools, we need to script everything that is automatable, we need to find anything that is a repeating task and automate it and script it, and we need to have essentially a DevOps / agile IT philosophy, right? So essentially automation is the thing that is key to the cloud and managing a large cloud. So keep that in mind going forward. You should be adopting a philosophy that says we need to find any single task that we repeat more than once. We need to find a way to automate that and do it in a way that's programmatic, do it in a way that's predictable and reliable and maintainable going forward. Very, very important to how you manage a cloud reliably. And so you say, great, that's great. We're going to build a bunch of tools. We're going to build a bunch of scripts. What kind of tools would you recommend that are cloud friendly? And one of the things, obviously, is it needs to be network capable. Clearly, it needs to be aware of the network there. The second is if it's cloud aware, that's great. And what do we mean by cloud aware? Does the tool support multi-tenancy? Is it tenant aware, or does it assume you have low-level kind of root access to your infrastructure? Is it easy to integrate? Oftentimes, you're going to have to be able to integrate these tools into other automation frameworks and be able to call them programmatically from somewhere else, right? And lastly, are there good standard of libraries of scripts, example scripts? Are they well established and well tested repositories that you can tap into that will allow you to automate better, right? So that these tools can be kind of deployed much more easily, and you could bring in best practices from other data centers that are very well run around the world into your infrastructure. So the types of tools that we're seeing out there that are like service tools, these are the tools that allow you to kind of bring up a bare metal VM, install the OS and the software stack, the initial software stack. You have the configuration tools that allow you to ensure that the server that you have, the virtual instance, or the topology that you have is in compliance with a certain set of parameters that you might have set, and a certain topology tolerances you have for that you've been able to patch all of these servers to the right levels of patch fixes and applied the right service packs and all of that. And then you have tools that allow for the automation and orchestration of the infrastructure itself. And finally, the last bucket is the monitoring, which is, what is the health of my cloud? How do I monitor it? These are the 4 different buckets, and we'll walk through some examples of open source tools in each of these buckets that are very useful for managing a cloud. The provisioning ones, there's probably, those of you who are very Linux friendly are very familiar with Kickstart, I'm sure, and similarly, Cobbler is another variant of that, and Spacewalk and Crowbar are others that have been put together. Crowbar more recently is being used by several of the cloud providers to bring up bare metal clouds and the bare metal hosts that make up a cloud, right? So these are some examples. I will, kind of in the interest of time, go through these fast, but, I put these up so you can see all the names of the different products that you may want to go research in each of these tools buckets, right? So the configuration management tools, I think Chef and Puppet are very popular nowadays. You should go understand how you can leverage them, and there are others as well that offer similar attributes. Almost all of these kinds of tools come with large libraries of scripts and repositories that are very leverageable, reusable, that make life quite easy for you when you're trying to configure your cloud and your instances. And in terms of monitoring themselves, again, there's a plethora of tools out there. The most popular, which Nagios and Xenos, and Cacti is a pretty good tool too, or all those kind of put out RRD kind of output. So you can use a whole bunch of RRD tools as well. So these are some of the choices available in the open source arena, right? In terms of orchestration, automation, again, you can also use, there's some overlap in some of these buckets. You might say, hey, but isn't Chef and Puppet in here too? Yes, I put them in the provisioning and the configuration management bucket, but, you could obviously refer to them as automation and orchestration tools. Here are a few more that we start to see, right, in terms of tools that are being used. Capistrano is very popular of recent, and building a good following, and there are some others as well for your consideration. And some of them are language dependent based on what kind of bindings you need and what kind of license you may, or what kind of intent you have for the use. So you may be somewhat license sensitive as well with the GPL or Apache if you're linking to some of these tools in products you're building, for instance. And you need to make sure all these tools are client server clearly. You need to be able to call and invoke these tools remotely, and almost all of them support that. So now let's talk about. So we talked about the 4 buckets of tools, and there's this whole new concept that's been developed in DevOps now, which is the tool chain, right? So what is a tool chain? It's a set of tools where the output of one becomes the input of the next, right? So essentially, tools in each of those buckets are useless if they cannot be orchestrated to work together in a chain. And there's this notion that we need to leverage tools from each of these buckets, but they need to kind of build together a cohesive management framework that you can use to manage your entire cloud, right? And so there's this concept of tool chain and so what does a tool chain look like? And at the bottom you have basically the bootstrapping. This is your bare metal install of basically first launching the VM itself, the instance, and then installing the OS. And I walked you through some of those tools. I'm just taking the same tools we had in the earlier buckets and mapping them to a layer cake kind of approach here, okay? The next slide, I'll show you the same tool chains except in a workflow type approach, right? So if you look at it from the layer cake approach, at the bottom you have the launch the instance, install the OS, bare metal, then configure the system, and then command and control. Let's monitor the applications, all of that, right? This is the the layer you have. If you look at it from the workflow perspective, this is the sequence of activities that you'll use, and here are some of the examples of tools that you use in each of these. You generate the image for the VM itself. You then kick off that VM. You might use, for instance, CloudStack to launch the VM. You might then provision all the assets inside that instance using something like Cobbler. You then maybe configure it using Puppet and Chef or a whole bunch of automation scripts, and then you might actually monitor this entire infrastructure using a whole bunch of tools like Rundeck maybe, and you'd monitor the entire the events and all of the health of the cloud using tools like Nagios, including the network and storage and all that, using Nagios and also Cacti. So this is where those tools map, right, in terms of the workflow. So now let's take a look at the Apache CloudStack project itself and where that is, where that can add value in your architecture of cloud. So Apache more recently has joined the Apache Cloud Foundation, the Open Apache Foundation, and this is essentially a new development, and Citrix has donated all of the code into the Apache Foundation, and in due course, once it exits the incubation mode, will become a full-fledged open source project, right? Joining some of the most popular software projects in the world: Hadoop, Cassandra, Tomcat, Apache itself, the Apache Web Server project, all of those. So this allows us to essentially provide a framework that is extremely open, an extremely vibrant, strong community that is governed by a very credible OpenStack community, right? And essentially an open source community. And we are joined there by over 50 customers and ecosystem partners that are allowing us to help and joining us in helping grow this CloudStack community within the Apache Foundation. And essentially our goal there is to align CloudStack with the Amazon Cloud Standard and help those that wish to build Amazon-like clouds for themselves using a very open source Apache-based project, and that's the high-level goal. And ensure great levels of interoperability across members of this community that all choose to adopt CloudStack. So what is CloudStack itself? And you can go take a look at CloudStack at the cloudstack.org URL. You can go download it and try it, but just a few bullets on what it provides. It's essentially the compute layer, and it provides you essentially the ability to manage across multiple hypervisors. So you can choose a hypervisor of your choice, and all the big popular hypervisors are supported, including Zen, Server, VMware's ESX, KVM, and Oracle. Are all supported today, so you can essentially have freedom of choice at the hypervisor layer. It provides a very attractive and very robust interface layer that's accessible over the web, and has a very sprightly UI, Ajax-y and everything. And it provides extremely flexible networking capabilities under the hood. And you're able to build clouds that have instances in them that have high availability monitoring built in. And your entire infrastructure can be built with a rich set of RBAC capabilities, so you can define admin roles and several different user roles that you might need to layer in your access controls. And it is entirely available through a programmatic UI, so API. I mean, so you can do pretty much anything you see in the UI through APIs as well. And I've already discussed the fact that it's licensed entirely under the Apache project now, right? So, in terms of the hypervisors, I mentioned these already, and I should add, we also support in CloudStack bare metal instances as well. So you can actually bring up a CloudStack cloud that is made up of bare metal machines, and essentially that's the equivalent of having essentially instances that are each individually a physical machine. There's multi-tenancy built in into the CloudStack architecture. So there's no interaction with the hypervisor directly, and there's no knowledge of the underlying storage at the tenant layer, right? And so essentially tenants and applications that run on top of CloudStack do not have access directly, right, to the underlying infrastructure. They come through the CloudStack API that enforces the tenancy very rigidly and very securely. In addition, there's network separation that is enforced as well on a tenant basis, and there are several options there, including VLANs and security groups. Quite flexible, and we'll dive into that later. And across tenants, you can actually dedicate pools of hardware that are dedicated to individual tenants if you need to. And so it's very flexible in the way the architecture supports both dedicated and shared infrastructure if the need arises. So networking itself is, there's a couple of models there for networking. One is essentially the VLAN and security groups model, and then you have basically the physical and hardware layer below, right? And CloudStack abstracts all of the physical for you into essentially two different kinds of models, one being the VLAN model and the second being the security group model. And you can use either of those, and obviously the VLAN model has some limitations in terms of the scalability, because the number of VLANs might be limited in your network, and so some folks that deploy CloudStack prefer to use the security groups model. And CloudStack manages all the network infrastructure for you and under the hood, and it provides you essentially an abstract layer above. So what are the elements that CloudStack actually will help you manage, and what are the services that CloudStack will expose? It provides you DHCP capabilities. It obviously allocates the VLANs, and it provides firewalling if you wish to instantiate those, and added port forwarding, and a whole bunch of other capabilities like routing, VPN, and load balancing if you want to instantiate those. So very rich capabilities on the networking side, all managed by CloudStack. In addition, it can actually manage physical network hardware as well. So, for instance, the F5, the NetScaler, the Juniper boxes can all be managed, and there's soft appliance versions of those as well. So, if you use a NetScaler VPX, for all practical purposes, that looks like a NetScaler hardware device to us at the CloudStack layer, and you can manage those from your CloudStack API and UI. Additionally, you can mix and match. So this is a lot of flexibility built into the topologies supported. So you can mix and match all the elements above that I've talked about for different tenants and even in different zones, right, within your infrastructure layer. So security groups, as I mentioned earlier, is essentially is an architecture that allows you to work around the limitations of VLANs, but at the same time providing isolation, right? Amazon uses a similar kind of capability in terms of how they provide isolation at the networking layer, right? So, obviously the assumption in security groups is that, the layer 2 network is quasi-trusted, and, it typically will only work when the network hypervisors are directly connected to the network. And the assumption in security groups is obviously deny by default, which is you'd have to set up the specific rules to enable certain ports to connect to certain others, both on the ingress and the egress points. So, in the interest of time, I'll move forward on the security groups. There's a couple of different ways in which security groups are architected, and there are more details available at cloudstack.org. So the next thing I want to talk about is kind of high availability, and high availability is really not a magical solution, but it's a useful kind of implementation that's available in CloudStack. It essentially takes away some of the hassle that you have in terms of maintaining your instances, but it's not as if the instances are replicated or anything like that. What high availability in CloudStack is essentially it monitors an instance. If it sees an instance is not available or unavailable or has been terminated for some reason, and if that instance were tagged to be highly available, then another instance is started up elsewhere in the cloud to ensure availability. And this requires essentially a redundant router to be available in there. as well. So that's the other way you can ensure that your network and your routing functions, your networking functions are all highly available by ensuring you have a redundant router. Again, how does the placement itself happen within CloudStack? There's several different options there that CloudStack ships with out of the box, and obviously, since it's an open source project, you can go ahead and build your own if you wish to. But most people find the options that are available out of the box are sufficient. There's the first fit, there's the fill first, and the dispersal kind of mode, right? Dispersal, if you want to load balance across your entire cloud, first fit is essentially pack it all into a single server before you go to the next one, right? And fill first is essentially use the last one used and keep going. And you can tag all your resources to create kind of groupings of resources and to be able to identify them inside your management layer and be able to do filtering of the resources and selection. And so tags could be used for that as well. And you could place based on OS preferences as well, in terms of the allocation of resources. CloudStack collects a lot of different metrics on the underlying infrastructure and the usage, and all of those can be exposed up the stack all the way up to the various portals and tools that will leverage those for either charge back or bill back or even monitoring, right? Several of the tools available today include the Citrix Cloud Portal product itself that leverages that, and others from some of our partners and some that have integrated to CloudStack. In terms of storage, there are several options there as well, which is essentially historically NFS is available, and Swift is available, and Caringo, and a bunch of others, and many more on the way that are being integrated as we speak for secondary storage. And secondary storage is managed by a VM that's running in the infrastructure, and that basically allows you to kind of do things like snapshot and move snapshots from primary to secondary, and even the aging of the snapshots and all of that. So essentially, you can effectively manage your storage more efficiently. Primary storage, and this is essentially storage that the VMs are running off of. Can either be NFS, iSCSI. You've got a lot of options there. You can basically even use local storage. The only caveats on local storage obviously are high availability is limited in terms of options because you're stuck on that single disk on the single host, and live migration, obviously, you would have to migrate to a different host, and if the VM was sitting on local storage on that host, that would make it a challenge. You could even mount shared mount, and anything that the hypervisors can mount and write to is supported essentially, and in terms of primary storage. So that gives you a lot of different flexibility across the board. In terms of the actual hierarchy, in terms of how CloudStack itself is organized, you have at the highest level zones, and you can have one or more zones. Within zones, you have pods, and then pods are made up of clusters. So this is essentially the hierarchy within CloudStack, and the namings will map to different, in terms of the actual names. I think the zone is very similar to the way you might think of an Amazon zone, and it's mapped similarly. Pods and clusters are maybe a little different than you might be familiar if you're familiar with the Amazon cloud, but they're all pretty logical and easily understandable. So essentially a zone is essentially something that allows you to provide geographic isolation, right? And all the secondary storage resources across the entire zone are common and available within a zone. And essentially, you would map a single network model for a zone, but you could have two different network models across two different zones if you need to. Zones individually can be different from other zones in the cloud, but typically in terms of network and storage, they would all be kind of homogeneous within a zone. A pod is essentially a rack of or a row of machines, and this becomes a little more difficult nowadays when you have things like blades that could actually be so dense and so highly pack that they could almost look like a pod by themselves, right? But anyway, in general, a pod maps in most data centers to a rack of machines or a row of racks, even potentially, depending on their architecture. And essentially, you would share a local network across the pod, typically in the way most people architect it, and that would be a shared guest network. A cluster is something that's a little smaller unit within pods. It allows you to potentially be able to address individual smaller subcomponents of your cloud. Essentially, you try to ensure a deep level of homogeneity across a cluster, and essentially try to ensure even the underlying hardware is very, very similar across a cluster. And typically, primary storage is very cluster specific. So if you basically have maybe 8 to 15 machines per cluster, and that's often kind of driven by the fact that the primary storage is shared across that entire cluster, and you want to maintain essentially almost identical underlying hardware across all of these, so it allows you to kind of be able to do things in terms of redundancy, in terms of fault management, or all that downstream later, much more easily if everything is homogeneous within a cluster. Now, you've got a whole bunch of networking options available in terms of CloudStack itself. Again, you've got at a very high level, you can build private networks, you can build public networks. Private networks can have a whole bunch of networking services available on them, and they'll expose a virtual soft router on those networks as well that will provide a whole bunch of services. The public network is oftentimes the network that is public-facing, i.e. internet-facing. The guest networks, those are the networks on which the VMs are provisioned itself, and you basically have all of this is controlled through both the CloudStack API and available in the console itself. So, in terms of the management server itself, there are a bunch of VMs that run and provide all the management capabilities that all the APIs call into, but typically all the state is stored in a shared MySQL DB that provides essentially high levels of reliability across the board. And all the UI functionality, right, as I've told you earlier, is API callable. So the API is essentially a RESTful API, and you can bind it to any programming language of your choice and be able to program and essentially drive CloudStack from the language of your choice and develop an environment of choice. So at this point, I'd like to open it up to questions and encourage you to call in and to the chat window with your questions. And give me a second, I'll try and bring up the chat window so I can see the questions. So, please enter any questions you have into the chat window. I will wait 30 seconds for the first. Okay, I got a question that says, is CloudStack available today? Yes, it is. It is shipping, and is actually in production at over 100 different sites around the world, and powers some of the largest private clouds around the world. So feel free to go across to cloudstack.org to download the bits and give it a whirl. So you can go out there and build out your private cloud. There's a very vibrant community that's available on the cloudstack.org website as well, where you can ask questions of the community and participate in including code contributions of your own to the project. So, question came in about are there CloudStack groups in India, and that is in the process of being created. And if you have interest in that, please feel free to engage. You you can email me at ravi.gururaj@citrix.com, and I'd be glad to connect you to the right folks that are setting that up. And you can also go to cloudstack.org, and they will I believe there already is a subgroup there for India. Feel free to participate there, and if you'd like to sponsor an event in your city that is CloudStack related, user group or any other special interest group that is interested in this space, we'd be glad to help you facilitate that. So you can reach out to me again, or ping the folks, the community managers at the cloudstack.org site. They'd be able to help you there as well. Okay, another question came in about the scalability of CloudStack. What's the largest clouds we're seeing out there? And essentially, the scale of CloudStack is, in terms of its architectural design, is literally unlimited. It can be horizontally scaled limitlessly, and today some of the largest clouds have run north of 25,000 physical hosts. So it's in production, and so it's proven to be very reliable at scale. So you should feel free to give that a test if you're planning to build a very large cloud, and we'd be glad to provide you information as and when you wish. Okay, I think the moderator has provided you my email address as well in the chat window. So if there are any other questions in the future, I'd be glad to address them. And hearing none others, I will close out this webinar then. And I believe the recording and the slides will be made available on the TechGig website at some point in the near future, if not already.
Thanks, Mr. Ravi, for your session on Crash Course in Open Source Cloud Computing. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all.